Again, that becomes important for the purposes of adjusting your hedge. Now, we only did what you want to call duration, valuation and duration and convexity for a bond, but a lot of times we deal with other cash flow structures. I'm gonna do a generic one. Let me delete this one. I don't need that one anymore. And let's make a copy of this blank. The only reason I have that so that I can use those buttons. Let's think about an arbitrary set of cash flows. So we're gonna write code that calculates A, present value of those arbitrary cash flows, B, calculates its duration, and calculating the convexity of that is not much of a problem. Even though I can do it for arbitrary, I'm gonna do it for a mortgage for 30 years, okay? So let's put in some of our inputs. Principal, $100,000. Mortgage rate. Again, this is the effective rate. I'm not going into APR's points. There is a way to figure those out, but it's not the topic of this class. Maybe I should teach a real estate finance class at some point. It's an elective. Because a lot of things are conventions, but you kind of need to know what they mean. Let's find out current market for that. It's always a good idea to use. So let's see. US 30. Right there, currently as of this morning, 698. So we're gonna do 7, okay? Years, let me put them here. Payment. I'm just going to go ahead and calculate it. There is actually an Excel function called PMT. The first argument is the rate. It's interest rate divided by 12 since we're doing monthly. Second argument is number of payments, years times 12. Third argument is the payments. I'm going to put a negative sign. Oh, third argument is, I'm sorry, the present value. I'm going to put a negative sign in front of that so that it produces a positive number. The fourth and fifth arguments are optional since there are no balloon payments. So let's make this big a little bit. Let's get some formatting going on. Remember, those are my inputs. You're probably thinking I'm spending too much time on that, but it's always a good idea to format your numbers correctly so you know what you're talking about. And payment is something I calculate. So I'm going to make format of that. 。 . 。  . 。 . 。 . . . . . . . . . . . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . remember my obsession with green lights and red lights. Green light is there my inputs, red light is it's something I calculated. Don't touch it. I can even protect them, but I'm not going to. Maybe if I have time, I'll show you how to do it. So that you wouldn't let your users do anything into any cell that you did not leave unprotected. A lot of times it's not a bad idea. Because if they use your sheet and they get a wrong number and they lose money, they could technically sue you. It doesn't matter, you say, buyer beware. All right. And I'm gonna call this years. Because I'm gonna calculate everything. Oh, no, let's leave it as months. And I'm gonna take all of these all the way down to 360. Again, I don't have to, but it doesn't take me that long to do it. These payments happen to be equal. But we're gonna set it up in such a way that we're gonna feed Excel or VBA the months and the cash flows, okay? Thanks. I'm going to put in the okay, let's call this periods. So if you have different compounding frequencies, you can handle it that way. First, I'm gonna do it on Excel itself, okay, or the worksheet itself. Present value of these payments, and let me calculate period rate. Take the mortgage rate divided by 12. And that's the payment divided by 1 plus the period rate, which is a fixed number raised to the power number of periods. All right. GD of payments should not be surprising to you at all. Right, sum of all of this, if I have done things correctly, that should be 100,000. But this is assuming the current interest rate is the same as the original one. So let's do this. Let's call this market rate.